You're standing on a dry floodplain in East Africa. It's 2.6 million years ago. There's no fire yet. There's no language yet. Not really. There's just you, a dead animal carcass swarming with flies, and a sharp-edged rock in your hand that you picked up about 4 minutes ago and haven't quite figured out how to use. This is the story of how humans became meat eaters. Not burger joints, not steakhouses, not the guy at the barbecue who insists his brisket recipe is a family secret. We're talking about the moment our ancestors looked at a dead animal and thought, I want that. And why that decision might be the single most important dietary choice any species has ever made. Because here's the thing, nobody tells you. Meat eating doesn't start with hunting. It doesn't start with spears or fire or the noble image of a caveman bringing down a mammoth. It starts with theft. It starts with scavenging, with sneaking, with grabbing scraps off a carcass a lion had already half finished. Our ancestors weren't apex predators. They were opportunists. And the evidence for how that opportunism rewired our entire species is genuinely astonishing. Let's start with what came before. Our earliest ancestors, the Australopithecines, ate mostly plants. Fruit, leaves, tubers, the occasional insect if they were lucky. Their teeth tell the story. Broad, flat molars built for grinding tough vegetation for hours a day. Their guts were long, built to slowly ferment fibrous plant matter, the same way a modern gorilla's gut works today. This was the baseline. This was millions of years of primate biology doing exactly what primate biology is supposed to do. Then something changed. Around 3.4 million years ago, at a site called Dikika in Ethiopia, researchers found something strange. Animal bones bearing what looked like cut marks. Scratches consistent with stone tools slicing through flesh to strip meat, and percussion marks consistent with smashing bone open to get at the marrow inside. If those marks are what they appear to be, and there's genuine scientific debate about this, it would push the use of tools to process meat back further than almost anyone expected. Before Homo. Before big brains. Before anything we'd recognize as remotely human. Now here's where the story gets clearer, because by 2.6 million years ago, the evidence stops being ambiguous. At Gona, in Ethiopia, archaeologists uncovered some of the oldest confirmed stone tools ever found. Simple cores and flakes, sharp enough to slice, hide, and tendon. And alongside those tools, animal bones with unmistakable cut marks. This wasn't an accident. This wasn't a rock that happened to scrape against a bone. This was a species learning, deliberately and repeatedly, that a sharp edge could open a body that its own teeth and hands never could. Think about what that meant. Suddenly, a small-bodied, slow, weaponless primate had access to something it had never had access to before. Fat. Protein. Calorie-dense tissue that took a lion 20 minutes to eat and would otherwise rot in the sun within a day. You didn't need to be fast. You didn't need to be strong. You just needed to be first, or clever enough to wait until the lion left, and quick enough to strip what you could before the hyenas showed up. Scavenging is not glamorous, but scavenging is smart. This is where the zooarchaeologist Henry Bunn's research becomes essential to the story. Bunn spent decades studying the bones at Olduvai Gorge in Tanzania, one of the richest early human sites on Earth, and his work on cut marks and bone breakage patterns revealed something crucial. Some of these early humans weren't just picking at leftover scraps after predators had gone. In certain cases, the cut marks lay directly beneath tooth marks, suggesting our ancestors got to the carcass first and predators or scavengers came after. That single detail matters enormously. It suggests active, early hunting, or at least aggressive, well-timed confrontational scavenging, happening far earlier than scientists once assumed. Our ancestors weren't just waiting around for scraps. Some of them were already competing directly with lions for the same kill. But why does any of this matter? Why would a shift in diet actually change what a species becomes? This is where we have to talk about the brain, because the brain is greedy in a way almost nothing else in the body is. A human brain today makes up about 2% of body weight, but burns roughly 20% of your daily energy at rest. That is an extraordinary metabolic cost. Somewhere in our evolutionary past, a hominin species had to find a way to pay that bill. In 1995, researchers Leslie Aiello and Peter Wheeler proposed an idea that became known as the expensive tissue hypothesis. Their argument was elegant. The gut is also metabolically expensive to run, especially a long, complex gut built to digest fibrous plant material. If a species could shrink its gut, it would free up enormous amounts of energy. But you can only shrink your gut safely if you're eating food that's easier to digest, food that's already calorie-dense and doesn't require hours of fermentation. Meat fits that description perfectly. Aiello and Wheeler argued that as diet shifted toward more meat and fat, The gut got smaller, and the energy that used to go toward digestion got rerouted somewhere else entirely. Somewhere upstairs. That single trade, gut tissue for brain tissue, may be one of the most consequential biological transactions in the history of life on Earth. Smaller gut, bigger brain. And a bigger brain over enormous stretches of time means better tool use, better social coordination, better memory for where the water holes are, better planning for tomorrow instead of just today. Meat didn't just fuel bodies. It may have quite literally funded the birth of human intelligence. Now, let's talk about a name you may already know, because his theory is one of the more provocative ones in this entire field. Richard Wrangham, a primatologist at Harvard, doesn't argue that raw meat alone explains the human brain. He argues that cooking does. His cooking hypothesis, published in the early 2000s, suggests that at some point around 1.8 million years ago, coinciding with the appearance of Homo erectus, our ancestors began systematically using fire to cook food, including meat. And cooking, Wrangham argues, changes everything. Cooked meat is dramatically easier to chew and digest than raw meat. It takes far less energy to extract the same calories. Wrangham's research suggests that the anatomical changes we see in Homo erectus, smaller teeth, a smaller gut, a body built for endurance rather than heavy chewing, line up almost perfectly with a species that had discovered fire and was using it to transform its food. Is the timing perfectly settled? No. The oldest confirmed, undisputed evidence of controlled fire, that Wonderwork cave site in South Africa, dates to around 1 million years ago, which is later than Wrangham's proposed timeline. But the anatomical evidence, the smaller jaws, the reduced gut capacity, is hard to explain any other way. Something changed the metabolic equation for Homo erectus. Cooking remains one of the most compelling candidates. Here's where you have to sit with an uncomfortable irony. Meat eating may have built the human brain. And the human brain may have been what allowed us to become terrifyingly good at getting more meat. This is the feedback loop at the center of the whole story. Better cognition led to better tools. Better tools led to more efficient hunting and butchering. More efficient hunting led to more reliable calories. More reliable calories fed a growing brain, which needed even more calories to sustain itself. It's a spiral, not a straight line. And once that spiral started spinning, it didn't really stop. By around 1.5 million years ago, we start seeing something new in the archaeological record. Hand axes. Not simple flakes anymore, but symmetrical, deliberately shaped tools requiring planning, foresight, and an understanding of how stone fractures. These are called Acheulean tools, and they represent a massive cognitive leap. A species making these tools wasn't just reacting to a carcass in front of it. It was imagining a future carcass and preparing for it in advance. That's not instinct. That's forward planning. And forward planning, in evolutionary terms, is expensive to build and incredibly valuable once you have it. Let's talk about isotopes for a second, because this is where the science gets almost eerily precise. When you eat, the chemical signature of your food gets locked into your bones and teeth, specifically in the ratios of certain carbon and nitrogen isotopes. This means researchers can actually measure, with real scientific confidence, roughly how much meat a prehistoric individual was eating just by analyzing a fragment of ancient bone. Studies on Neanderthal remains across Europe have produced some remarkable results. Nitrogen isotope ratios in Neanderthal bones are consistently as high as those of top-level carnivores like wolves and hyenas, not omnivores dabbling in meat occasionally. Apex-level carnivore signatures. Neanderthals, it turns out, were eating enormous quantities of meat, likely from large game like mammoths, bison, and reindeer, and doing so as a dietary staple, not an occasional treat. That finding surprised a lot of people, because Neanderthals have a reputation, largely undeserved, as brutish and unsophisticated. But hunting mammoths with wooden spears and stone points requires coordination, courage, and communication at a level that's honestly humbling to think about. You don't take down an animal that size by accident. You take it down with a plan, with teamwork, and with an understanding of the animal's behavior built from years of observation passed down through a group. That's not brute force. That's culture. So when did modern Homo sapiens enter this picture, and what did we do differently? By the time our species emerges in Africa, roughly 300,000 years ago, meat was already deeply embedded in the human dietary toolkit, alongside a much wider range of plant foods than Neanderthals typically relied on. This is an important distinction. Homo sapiens weren't necessarily eating more meat than Neanderthals. In many cases, they were eating a broader, more flexible diet: shellfish, fish, tubers, nuts, seasonal fruit, alongside hunted game. That flexibility may be part of why our species survived ecological shifts that other hominins didn't. There's also a social dimension to meat that rarely gets enough attention, and it has to do with sharing. A single plant you forage, you can eat alone, quietly, without anyone noticing. A large animal carcass is different. It's too much meat for one person to consume before it spoils. It has to be shared, distributed, negotiated. Anthropological studies of modern hunter-gatherer societies, including extensive fieldwork among groups like the Hadza of Tanzania, show that meat sharing isn't casual generosity. It's governed by intricate social rules, obligations, and reciprocity that bind a group together in ways plant foods simply don't require. When you bring down a large animal, you don't just feed your family. You feed the group, and in doing so, you build alliances, debts, and trust that could keep you alive during the next lean season when you're the one who comes home empty-handed. Doesn't that reframe the whole picture? A kill wasn't just calories. A kill was social currency. It was the ancient equivalent of a safety net, built one shared carcass at a time, across generations, long before anyone had a word for insurance or economy. Now here's where the story takes a turn that connects directly to the world you're living in right now. Meat eating stayed relatively stable, hunted, wild, seasonal, for the vast majority of human history. Then, roughly 12,000 years ago, agriculture happened. And with agriculture came something entirely new: domestication. Instead of chasing a herd of wild aurochs across a floodplain, humans in the Fertile Crescent began keeping goats, sheep, cattle, and pigs close, breeding them, controlling their reproduction, and essentially converting meat from an unpredictable windfall into a manageable, renewable resource. This changed the entire relationship between humans and animal protein. Meat went from something you risked your life chasing to something that lived in your village, ate your scraps, and was there whenever you needed it. Population density increased. Settlements grew. And with domesticated animals came something darker too. A whole new category of disease. Because living in close quarters with animals meant pathogens could jump species in ways they rarely had before. Measles, likely from cattle. Influenza, likely connected to domesticated birds and pigs. The convenience of reliable meat came bundled with a biological cost nobody saw coming. For thousands of years after that, meat consumption looked wildly different depending on where you lived, how wealthy you were, and what animals your region had managed to domesticate. In much of the ancient world, meat was actually a luxury, not a staple, reserved for feasts, ceremonies, and the wealthy, while ordinary people ate diets built mostly around grains, legumes, and vegetables, with meat appearing only occasionally. That pattern held, more or less, for thousands of years across most agricultural societies. So what changed? What turned meat from an occasional feast food into the daily, industrial-scale product it is today? The honest answer is refrigeration, transportation, and industrial agriculture, and all three arrived astonishingly recently. Before mechanical refrigeration became widespread in the early 20th century, meat had to be consumed quickly, salted, smoked, or preserved through labor-intensive methods, which naturally limited how much of it moved through the food system. Once refrigerated railcars and later refrigerated trucking systems became standard, meat could travel enormous distances without spoiling. Combine that with the rise of industrial-scale feedlots and selective breeding for faster-growing livestock, and within the span of about a century, meat transformed from an occasional luxury into a cheap, constant, everyday product available in nearly unlimited quantity to a huge portion of the world's population. Isn't that a strange thing to sit with? For nearly 3 million years, meat was rare, hard-won, deeply social, often ritualized, and metabolically transformative to the species that pursued it. And then, within the last 100 years or so, an evolutionary blink of an eye, it became the opposite. Abundant. Constant. Barely thought about. You can walk into almost any grocery store on Earth right now and buy more meat in 10 minutes than an entire Paleolithic hunting party might have eaten in a month. There's a real cost to that shift that goes beyond nutrition science, and it's worth sitting with, honestly. The industrial meat system that emerged over the last century is enormously resource-intensive, contributing significantly to land use, water consumption, and greenhouse gas emissions on a global scale. The very thing that once required extraordinary skill, patience, and social cooperation to obtain has become, in its industrialized form, one of the more environmentally costly aspects of modern life. The ancient hunter who spent days tracking a single animal and treated its death with something close to reverence would likely be stunned by what that relationship has become. But let's come back to biology for a moment, because there's one more layer to this story that ties everything together, and it involves something you probably take completely for granted: cooking fire. Humans are, functionally, obligate cooks. Unlike almost every other animal on the planet, we've lost some of the raw digestive capacity our ancestors once had, precisely because cooking did so much of that metabolic work for us externally, outside the body, over a flame, before the food ever reached our mouths. Wrangham's research points out that humans attempting to survive purely on raw food diets today, even nutritionally sophisticated modern raw diets, often struggle to maintain adequate body weight and energy levels, particularly women of reproductive age. Our bodies, quite literally, expect food to already be partially broken down before it arrives. That expectation was built by millions of years of cooked meat and cooked starch doing metabolic work that our ancestors' guts no longer had to do themselves. In other words, you are not biologically equipped to be a purely raw food species anymore. Somewhere along the way, evolution made a bet on fire and never looked back. And that bet reshaped nearly everything about what a human body is and needs. So where does that leave the bigger question? Did meat make us human? That's probably too simple a way to frame it, and most researchers studying this today would resist that exact phrasing. It's more accurate to say that meat, combined with fire, combined with tool use, combined with intense social cooperation, created a feedback loop unlike anything else in the animal kingdom. Remove any single piece of that loop, and the whole story probably unfolds differently. No stone tools, and that early scavenged meat stays mostly out of reach. No fire, and the metabolic savings that likely fed brain growth never materialize. No sharing, no social trust, no cooperative hunting, and even the boldest hunter probably starves alone rather than eats well as part of a group. What the fossil record, the isotope studies, and researchers like Bunn, Wrangham, and Aiello and Wheeler collectively suggest is that our relationship with meat isn't a footnote in human evolution. It might be one of the central engines of it. A dietary shift that started with theft and desperation on an East African floodplain may have, across millions of years, rewired our guts, expanded our brains, restructured our social bonds, and ultimately produced a species capable of asking, thousands of generations later, how any of this happened in the first place. There's something almost humbling in that. Every time you sit down to a meal today, whether it's a quiet plate at home or a shared table with people you love, you're participating in a behavior with roots stretching back nearly 3 million years to a moment when a small, vulnerable primate looked at a dead animal on a dry plain and made a choice that would eventually build the mind capable of understanding that choice at all. You're standing on a dinner table tonight, and somewhere behind you, if you listen closely enough, that first sharp-edged rock is still striking bone.